Steel surfaces are frequently cleaned by abrasive impact prior to the application of protective coatings. This process removes previous coatings and roughens the surface to improve coating adhesion. The resultant surface profile is comprised of a complex pattern of peaks and valleys, which must be accurately measured to ensure long-term coating performance. A surface profile height that is too low may reduce coating adhesion and corrosion resistance. Too high, and the peaks may receive insufficient coverage, leading to premature rusting and requiring additional paint to cover the anchor profile. Testex Press-O-Film replica tape is simple, relatively inexpensive, and one of the most popular methods for measuring surface profile. This method also works on curved surfaces and has the option of retaining a physical replica of the surface. It conforms to test methods such as ASTM D4417-C and ISO 8503-5. When paired with the PosiTector RTR replica tape reader, measurements are digital and can be stored, saved, and reported with ease. DeFelsko's other solution for measuring surface profile, the PosiTector SPG surface profile gauge, uses a digital depth micrometer fitted with a fine-pointed probe to measure profile height. Learn more about the PosiTector SPG and the How to Measure Surface Profile using the PosiTector SPG video at the link in the description below. Replica tape consists of a layer of compressible foam affixed to an incompressible substrate. When pressed against a roughened surface, the foam collapses and forms an impression of the surface. Placing the burnished tape between the anvils of a micrometer and subtracting the thickness of the incompressible substrate gives a measurement of the distance between the peaks and valleys of the surface profile. Before testing, it is important that the surface is free of contaminants. Cleaning putty can be used to remove dust, debris, or residual blast media from the surface. Firmly press the putty onto the surface using your fingers and remove. Multiple grades of replica tape are available for different surface profile heights, as indicated by the scale printed on each piece of tape. Start by choosing a grade of tape appropriate for the expected profile height. To begin, pull a single adhesive-backed piece of replica tape free from its release paper and apply it to the blasted surface. Press the adhesive-backed ends of the tape to hold it firmly in place during the burnishing process. Compress the foam using the rounded end of the burnishing tool. Apply sufficient pressure in a circular and XY rubbing motion to produce a replica with a uniform pebble grain appearance. Avoid excessively hard burnishing as the tape could become distorted. It normally takes up to 30 seconds to fully compress all parts of the foam. After burnishing is complete, remove the replica tape from the surface. There are two common methods to measure the replica tape after it has been burnished: the analog snap gauge or the digital PosiTector RTR replica tape reader. PosiTector RTR probes connect to the interchangeable PosiTector platform, quickly transforming from a replica tape reader to a coating thickness gauge, dew point meter, gloss meter, and more. Before measurement, it is important to clean the anvil surfaces. For the replica tape reader, swipe the included cleaning card through the probe opening a few times while firmly pressing both probe buttons. With the surface and anvils free from debris, the PosiTector RTR is ready to measure. Power up the gauge by pressing the center button. When prompted, simultaneously press and hold both probe buttons firmly until the gauge beeps and the arrows point outward. There is no need to make an adjustment as required with other micrometers, since the instrument automatically subtracts the thickness of the incompressible substrate. For the snap gauge, adjust the 0 point to read -2 mils or -50.8 microns. To verify each instrument is operating correctly, measure a shim of known thickness. Ensure that the reading is within tolerance of both the instrument and the shim. Once the instrument has been prepared and verified, insert the burnished replica tape so that the measurement anvils are aligned over the burnished area of the tape with the adhesive side down. Once positioned, firmly press both probe buttons simultaneously and hold until the instrument beeps and the surface profile height H measurement is displayed. A constant anvil pressure is applied to the replica tape regardless of how hard the buttons are pressed. If using a snap gauge, slowly release the lever and read the indicated thickness from the display. ASTM D4417-C recommends that 2 replica tape readings be taken at each location to constitute a measurement. If the measured thickness of the first piece of replica tape falls within the overlap range, the next grade of tape should be used for the second measurement. If both the first and second measurements are within the overlap range, average the two measurements. If the second reading is outside of the overlap range, take a third reading using that grade of tape and average the second and third readings together. The PosiTector RTR includes a linearization feature which allows the user to use only one grade of tape even in the overlap range. Ensure that the correct grade of replica tape, C or XC, is shown in the upper left corner of the gauge display. Simply take two readings using the same grade of tape and average them together. While the PosiTector RTR-H is ideal for measuring profile height, the PosiTector RTR 3D additionally features an imaging system that shines light through the tape and captures a photo, generating a 3D image of the surface. From this image, important parameters such as peak count and peak density can be measured. Recent studies have shown that peak count is as important or more important than profile height in predicting coating adhesion and long-term performance. The PosiTector RTR 3D digital replica tape imager measures and records 14 common 2D and 3D parameters. Download 3D SDF files for analysis into PosiSoft Desktop, then use the free SDF viewer to extract and analyze a trace from the 3D plot. Change filtering settings and view 2D and 3D parameters from the easy-to-use interface. Replica tape has been used to measure the profile of abrasive blasted steel since the late 1960s. Its operation is described in a number of international standards, including ASTM D4417, ISO 8503-5, and NACE SP0287. Compared to other methods, it has the advantages of ruggedness, relatively low startup cost, good repeatability, and the option of retaining a physical replica of the surface being evaluated. DeFelsko's PosiTector RTR-H and PosiTector RTR 3D make this widely used and understood method even easier.